The working mechanism of ChatGPT is based on advanced artificial intelligence, AI, and natural language processing, NLP, techniques, which are powered by deep learning models, specifically transformers. Below is an explanation of the core components and processes that enable ChatGPT to function. 1. Transformer architecture. ChatGPT is built on the GPT, Generative Pre-trained Transformer, architecture, a type of deep learning model that excels in handling sequential data, like text. Transformers were introduced in the paper Attention is All You Need, 2017, by Vaswani et al., and they've revolutionized the way language models are designed. The key features of transformers that make them so powerful are: self-attention mechanism. This allows the model to focus on different parts of a sentence or text, even if they are far apart. It can capture relationships between words, regardless of their position in the input sequence. Positional encoding. Since transformers don't inherently understand the order of words, they use positional encodings to track the sequence of words in a sentence or paragraph. 2. Pre-training and fine-tuning. ChatGPT follows a two-step process of training, pre-training. During pre-training, the model learns from a massive corpus of text data from diverse sources like books, articles, websites, etc. In this phase, the model is taught to predict the next word in a sequence, given the previous words. This helps the model develop a broad understanding of language, grammar, facts, and some reasoning abilities. Pre-training is done using unsupervised learning, meaning the model doesn't require labeled data, it simply learns patterns and structures in the text. Fine-tuning. After pre-training, the model undergoes fine-tuning on a more specific dataset, often with human reviewers providing feedback. This phase helps the model align more with specific tasks, such as answering questions, following instructions, or maintaining coherent dialogues. In the case of ChatGPT, reinforcement learning from human feedback, RLHF, is often used during fine-tuning to improve responses based on user interactions. 3. Tokenization. The model doesn't process raw text directly, but breaks it down into smaller units called tokens. A token might be a word, part of a word, or even punctuation. For instance, the sentence "ChatGPT is amazing" might be tokenized into "ChatGPT is amazing!" By breaking the text down into tokens, the model can efficiently process and understand language at a more granular level. 4. Contextual understanding. Once the model is trained, it processes user input in chunks, called prompts. The prompt can be a question, a sentence, or a paragraph. The model uses its prior training to understand the context and generate a relevant and coherent response. The model processes the input using the self-attention mechanism and makes predictions based on patterns it has learned. The model doesn't understand language in the way humans do, but it generates responses that appear coherent and contextually relevant based on patterns learned during training. This ability to generate human-like text is powered by the model's vast number of parameters, often in the billions, which store learned knowledge about language and the world. 5. Autoregressive generation. ChatGPT generates responses autoregressively, meaning it predicts one token at a time, using the tokens it has generated so far as context for predicting the next token. This is done iteratively until the model produces a complete response or reaches a predefined length. The autoregressive nature allows it to generate dynamic, diverse, and coherent replies. 6. Temperature and sampling. When generating responses, certain parameters, like temperature, control the randomness and creativity of the output. A higher temperature, e.g., 1.0, generates more diverse and unpredictable responses, while a lower temperature, e.g., 0.2, results in more focused and deterministic replies. The model also uses techniques like top case sampling or nucleus sampling to ensure diverse but relevant outputs. 7. Reinforcement learning from human feedback, RLHF. In addition to the supervised training process, ChatGPT is fine-tuned using reinforcement learning from human feedback. In this approach, human reviewers rank different responses generated by the model based on quality, e.g., helpfulness, correctness, informativeness. The model is then trained to generate responses that are more aligned with human preferences by receiving feedback from these ratings. This helps make ChatGPT more user-friendly, engaging, and contextually appropriate in conversations. 8. Limitations and ethical considerations. While ChatGPT is highly powerful, it has several limitations. It does not have real-time access to the internet or the latest information. It can only generate text based on the data it was trained on up to a certain point in time, e.g., September 2021 for GPT-3 and early 2024 for GPT-4. It can produce incorrect or biased information because it learns from a large, unfiltered dataset. The model does not have true understanding or consciousness. It mimics human-like responses based on patterns, without genuine comprehension or reasoning. In summary, ChatGPT works by leveraging a deep learning model called GPT, Generative Pre-trained Transformer, which is based on transformer architecture. It learns patterns in large datasets through unsupervised learning, pre-training, and refines its responses through fine-tuning and reinforcement learning. Using techniques like tokenization, self-attention, and autoregressive generation, ChatGPT processes input text and generates relevant, contextually aware responses in real time. The system's ability to understand language and generate meaningful text is the result of vast amounts of data, sophisticated algorithms, and human-guided fine-tuning. However, it's important to remember that while ChatGPT generates text that seems intelligent, it operates entirely based on statistical patterns rather than true comprehension.